Okay. These notes, I think you'll find somewhat of a reprieve from what we've been working on. It's kind of a collection of some previous sections that we've had where we've used our compass. You're not using your compass and protractor, but we have had lines of reflection, and we've had shapes that we've reflected over the lines so that when they're on the other side, basically they're flipped. Okay, well, that's what symmetry is. Okay, you have lines of symmetry that split a shape in half, so that if you were to fold it over that line of symmetry, it's the same shape on one side of the line that is on the other. Okay, so this is kind of a continuation of this. Also, we will have something that we've had in a previous section, so I'm going to recall your brain. Hopefully it's awake this morning. When we did rotations with our compass, and remember we did an activity that had dots that were on the outside, and then there was a dot in the middle, and then a triangle. I remember we put the tracing paper on it, and we traced the triangle, and then we rotated until the dots matched up, and then we traced it again. Okay, well, that has rotational symmetry. It's the same shape that's being rotated however many degrees. Can anybody remember how we figured out what that rotation was when we had one triangle and then it rotated to the next triangle, and I said we could figure out what that angle measurement was? Remember what we did? So we're taking a triangle, rotating it, and it went all the way around, and we said we could figure out what each rotation was. Okay, the dots, or we also had triangles, right? So we counted how many dots or how many triangles were repeated, and we did what with that? Divided it into what? 360. Okay, so that's going to carry over to this section. Okay, but again, you're not going to have to use your compass. You get to freehand it, and this becomes very entertaining. It already started last period when somebody was trying to draw their reflection. We get to see who the true artists are in this class. Okay, so symmetry and polygons. So before I get started on this, reminders, important, especially my D's and F students and even my C students. There's some big grades coming up at the end of this semester. Please do not stop and give up. Remember, this is a graduation requirement, and you don't want to have to pay $100 to try to recover something that you could be like doing right now in class. So 5 more school days before Con is due. Con is due midnight, Sunday night. So it stamps it when you submit it. So I know when you actually did it. Okay, so we will check them when you come to school on Monday. You're going to log into your account, and then that's to get them. So if you are trying to do it and staying up past midnight, those will be considered late. So please do not put those off. These were assigned in August. Okay. So Con, make sure those are done. When we get done with the notes, I'm going to hand out a grade check. That's another 100 points test grade. Make sure you get that home and get it signed. I had several last time that didn't hand it in. That's a 0 on a test. That's, you know, what happens to a test grade that's a 0 to your grade is going to drop significantly. So get those signed. Okay. And on Friday, I will hand out an organizer for you to organize your notebook. That'll be due on that Monday as well, following that. And then other than that, finals. If you have to take finals, it's 20% of your grade. If you don't have to take it and want to come in, I'll have like sign up things on the board when it gets closer to the time. I'll have the names on there that have to come in. Those that want to come in, you'll put your name in a different color on the board, and then you just see if it helps your grade. Because some people are like C's, and parents are going to kill you if you don't have a B. You can come in and see if the final will raise you, but that you can't have a C in the class and get a C on the final and expect it to raise you. Okay. The test is cumulative, and know that it's pretty much takes up the whole, 90 minutes that finals are. So, but finals are 20%. Any questions on any of those? Okay, so back to the notes. Okay, so symmetry and polygons. Okay, so they start off with drawings and asking us to figure out what a polygon is and what a polygon isn't. Okay, so these drawings on the left, these 4 here, they're saying are polygons. The ones on the right, they're saying are not. So if we can compare the left to the right, what would you say a polygon is or isn't?
A polygon is a closed shape.
A closed shape. Okay, so all the ones on the left-hand side, they all meet up, where this one right here doesn't. Okay, what could be another one? That's another thing that a polygon is or isn't. Comparing the left pictures to the right. There's a couple more.
They all have straight lines.
They all have straight lines, right? So all the ones on the left have a straight line. This one over here does not have a straight line. So it has to be a straight line. It can't be curved to be a polygon. Yeah.
Two-dimensional?
Okay. So, and the word that they use when you wrote your definition is it's a plane. Okay, so it's a plane figure. It's not three-dimensional, so it's not this one right here. It's a plane figure, so a flat figure. One more. Looking at. Okay, so, and what that means is any of them that are crossing each other, that you've got, like here you've got 1, 2, 3 points, okay? But they're all in a straight line. You can only have 2 points that are in a straight line. So you can't make multiple shapes, basically, is what that means, okay? You can only make one shape. So here, over here, these still only intersect and have the endpoints, so they don't cross each other and intersect and make multiple shapes, okay? All right, that pretty much sums it up. So now looking at our first part of our vocab, a polygon is a plane figure, okay, so it's not 3D, formed from 3 or more segments. So that means it is at least the smallest would be what type of shape? 3 sides, a triangle, okay. 3 or more segments such that each segment intersects exactly 2 other segments, one at each endpoint, and no 2 segments with a common endpoint are collinear. So in other words, they don't cross and make another figure. You can only make one shape, okay. The segments are called the sides, so sides and segments. And then the endpoints where they meet at are called the vertices or the vertex of that shape. Okay, and we talk about them being the angles, and that's what vertex or vertices means. Okay, this chart, for a while, you will probably need to look these up. By the time the test comes, you'll need to have these memorized, which we will practice it over and over. Pretty much every worksheet asks you to name the shape, so you'll get used to calling these. Triangles, common one. Okay, we probably already know what that one is. Quadrilateral, so quad meaning 4. Okay, so it could be a square, rectangle, pentagon. Remembering that one, maybe by the building that's in Washington. I don't know if that helps you or not. The way that I remember hexagon and heptagon, because that's the one that I get flipped. Okay, try to remember which one's which. Is I think of the number 6, and the number 6 has an X in it. So hexagon, so there's an X in it. That's how I remember the difference between those two, because I like to get those two flipped around. Octagon's pretty easy to remember, because octopus, I think 8. Hopefully you know that an octopus has 8 arms. So octagon. Nonagon, decagon. Deca meaning decade. Okay. I think they got bored and they were like, yeah, I don't know what to name this one, so we'll just call this one 11gon, which just means there's 11 sides. Then they go back to, let's name this one. So deca meaning 10, but then they add do meaning 2. Okay, so dodecagon, so they added 2 onto the 10, and then they got bored again. Okay, so from the unlucky number 13 on, you just, however many sides there are, you would put that in front of the gon. So like 20 gon, 18 gon, okay, 15 gon. Okay, so 11 gon was one they got bored with, and then they came back with dodecagon, and then from 13 on, it's just a gon. Okay, equal angular and equal lateral. So equal angular means all of the angles are the exact same measurement. Equal lateral means all of the sides are the same. So again, you need to get used to this word. They're going to say if it is, we have it on today's worksheet. If your shape is regular, regular means that the sides and the angles are equal. Okay. So if it is a regular polygon, then we can find the central angle. Okay. So the central angle is the shape that repeats itself, like we were talking about the dots and the triangles that we had in a couple of sections ago when we had our compasses and rotated. Okay, so they're saying that this shape is a regular polygon because all of the sides are the same, and then I stretched it out in the book. It's stretched out evenly. Okay, but this is a regular polygon, so we can figure out what the central angle is. So what they're saying is you would draw a line out to all of the vertices, and then this shape repeats itself going all the way around. And you would count how many there are, or just count how many sides there are, and you would divide that into what again? 360. Okay, so we would divide this into 360. This would be our central angle. And then that would tell us what each of those rotations were to get it to be to the same. Okay, so central angle, it has to be a regular polygon in order for you to find that out. Okay, I think that's it on that. Okay, reflectional symmetry is what we did when we reflected it over a line. Now you're going to actually have shapes that you will either draw the line of symmetry. So if you put the line in the shape, that if you were to fold it over that line, whether it's horizontal, diagonally, whatever, it's going to be the same. It's just flipped. Okay. Some of your shapes, it'll give you half of the shape and say this is the line of symmetry or axis of symmetry. Draw the other half. Okay. Do your best. If it bugs you not to have it perfect, I've got tracing paper there. You can. Otherwise, I'm not going to judge you. I might laugh at you, but I'm not going to judge. Okay. So axis of symmetry means line of symmetry. Okay. Where is the reflection line? Okay, so example. We've got shapes here. So they drew in the axis of symmetry, that if you were to fold it, the sides would match up. Okay, so the left side of the bug, fold it over, would match up with the right side. This was supposed to be an isosceles triangle, meaning that there's only, right? It's supposed to be that right side triangle, an isosceles triangle, so when you draw it going, the left side matches up with the right side. Okay. For an E, where would the line of symmetry be? The capital E, so it's right there. So when you fold it, top, go down to the bottom. And then this diamond shape, horizontal, so it fold down. The vertical line to the left to match up with the right. Okay, so you'll be doing that. You'll just draw on the lines of symmetry. Or they'll have the left side of the bug, and they'll say this is the line of symmetry, draw the other side. Okay, so going back and forth. But it has to match up. Okay, vocab that you should have been exposed to previous to this class, I hope. Equilateral means that you have three congruent sides, so equilateral, lateral means sides. If it's an isosceles triangle, then that means you have two congruent sides, so I had that one drawn up there on the right, the green. And then scalene means that you have no congruent sides. Okay, so this all has to be classifying it by the sides. Okay, and then examples of it. So you put tick marks on the side saying they're all the same. Isosceles would only have two tick marks saying they're the same. And then scalene, all the tick marks going on around the outside would be different. Okay. So I believe we have something to fill in, I think is the next thing. This chart. So in your notes, equilateral. So if you were, because I can't draw it on there, it's not going to let me. If you were to have a drawing of an equilateral triangle, how many lines of symmetry could you draw so that if you were to draw it going through it, that you could fold it and the sides would match up? 3. Okay, so you're going to fill in another 3 in your first line. How many congruent angles are in an equilateral triangle? 3. If there's 3 sides, there's 3 angles that match up. Okay, isosceles. Isosceles has the 2 congruent sides. We just talked about this one because you have a drawing and I have it up there. How many lines of symmetry do we have on that one?
4.
Just 1, just right down the middle so that the 2 sides can match up. Okay, how many angles? 2. If we have 2 sides, then that means we have 2 angles that are congruent to each other. Okay, scaling, how many lines of symmetry? None, right? Because if you're to split it, if none of the sides are the same length, then you can't fold them and have them match up because none of them are the same length. Okay? So there is no line of symmetry. How many congruent angles? 0. There's no sides that are equal, then there's no angles that are equal. So the sides and the angles match up. Okay, we good? Okay. Next, fill in the blank. Okay, so I already have it drawn on the board for you, the isosceles, because we can do this to any, well, we can do it to the equilateral and the isosceles, but we're looking at the isosceles one over there on the right, the green one. For the fill in the blank, it says, an axis of symmetry in a triangle is the blanky blank of the side it intersects. Okay, so looking at our drawing up here, my axis of symmetry, they're saying when the axis of symmetry goes through the side, what does it do to that? What is that? Close. Because I'm talking about the side, so we're looking at the word angle. It's a bisector. Perpendicular. It's the perpendicular bisector. So if you want to use upside down T for perpendicular, that's fine. So the axis of symmetry is the perpendicular bisector of the side that it intersects. So perpendicular bisector. And then it passes through, and then this is called something with the angle up here, and it starts with a vertex. It passes through the vertex of the angle opposite that side of it. Right. Good job. So perpendicular bisector and then vertex. Okay. Rotational symmetry. Okay, so we just talked about this flashback from our previous section. If it doesn't rotate, obviously that's zero rotation. Going all the way back to the original, so full circle would mean 360. Okay, so it needs to coincide with the original. So anytime you rotate it, that if you were to look at the picture, it needs to look like the original because it would have rotational symmetry. Okay, so example here. So if we were trying to find the rotational symmetry and they're saying all these petals are exactly the same, we would divide 360 by what? What? 5, because there's 5 petals. Okay. So another example, not that one. We'll come back to this. Another example that they have is this windmill, and it says that it has rotational symmetry. What would we divide that one by? 4. So if on this, when it asks you to list in the section, and we'll have a reteach that has that, list all of its rotational symmetries, they're asking you for each one of them. So if this one rotates 4 into 360 would be what? 90. So the first one rotates 90, and it would look like the original. Then if it rotates again, another 90, that would make it how much? 180. Okay, so when you list them, you're doing it by 90s or whatever the number is. So when you divide it by 2, then it's going to be 180 and 360. So you list all of them when they've been rotated. Okay, so it'd be 90, then it'd be 180, then it would be what? It's another 90 from 180. Add it on to 180. 180 and 90 is, what's 90 times 3? 9 times 3 is 27 out of 0. So 270. So you'd have 90, you'd have 180, 270, and then back to the original 360. So when they ask you to list them all, you're just adding on whatever that original one was for all of them. Okay, we need to go back and fill this in. Okay, so filling this in is just the formula. This symbol right here just means central angle. So finding the central angle. Okay, so central angle, we did what? What are we divided into? 360. So you're going to write 360 right here with a fraction bar. And then below the fraction bar, you're going to use the letter N, just because they said it's N sides. So however many sides repeat, or petals repeat, or blades repeat, that's what you're dividing into 360. So finding central angle is 360 divided by whatever was repeated. Okay? All right. Not a muss.